Concept generation and evaluation. Here you can see the learning objectives of this lesson. At the end, you should understand the importance of creativity, innovation, concept generation, and critical evaluation in engineering design. You should be able to apply strategies and formal methods to generate concepts and know techniques for the evaluation of design concepts, and be able to apply analytical hierarchy process, AHP, for evaluation of concepts. We started with needs assessment, and we stated the problem and the objectives. Next, we have to specify requirements, what we call requirements specification, and then we have to generate, or we have to work on concepts. Creativity and innovation are quite critical in generation of concepts. Usually, we need to create something first in concept generation, and then make a judgment, so evaluation. Creativity is used to generate some novel ideas, so what we call concepts in this case, and judgment will be used to evaluate and select the best idea or the best concept. Both of these skills can be improved somehow. Creativity is quite related to the culture, educational system. On the other hand, innovation is somehow related to creativity. With creativity, we create novel ideas. Now, in innovation, we simply bring those creative ideas to reality, so on the implementation phase. Innovation and creativity have been quite popular and desired by companies because they play key role in creating new services and products. In concept generation, we can consider two different search approach categories: internal searching or external searching. In internal searching, as we can understand from the term, we need to work with the team members. And in this category, we have brainstorming, brainwriting, nominal group technique, NGT, concept table, and concept pen. The next slides will be going over each of this. External searching, as expected, literature survey or review, searching or reviewing some existing products similar to the product that we would like to design, and benchmarking similar products, sometimes interviewing some experts in that domain. As you might remember, nominal group technique, NGT, was also mentioned in lesson 2. Brainstorming, here you can see the rules for team brainstorming. It's usually not structured, but there should be a facilitator. One of the members of the team should be facilitator, presiding the meeting somehow. In this concept generation method, brainstorming, we do not judge or evaluate any idea. We simply encourage all members to generate ideas and try to focus on quantity not quality. We do not evaluate whether an idea is very valuable or a stupid one. Doesn't matter. You generate as many ideas as you can sell. You can generate. Usually, to generate an idea, you have to somehow stick to available systems or service or models. And for this purpose, we usually generate ideas based on either combining or modifying of available systems. SCAMPER is an acronym, is used to how we do this: substitute, combine, adapt, modify, put to other use, eliminate, rearrange, or reverse. So we simply take a system and we can take just one component of the system and we can simply substitute that component to generate a new idea. We can do this either combining, adapting, modifying, or put to other use, eliminating, or rearranging, or reversing. All ideas in brainstorming should be recorded carefully. Brainwriting, we simply develop a problem statement first as a team, and then read the problem state loudly. So all members should be aware of the problem that they will focus on. Each member writes ideas down on a card and then place it in the center of the table. And other members take cards from the pile and use the ideas created by the previous one to generate new ideas and usually build upon their ideas. Alternatively, members can generate an idea and write it on a card and then pass it to the member next to him or her. And each member then builds upon the idea passed to them. This is similar to somehow brainstorming and NGT. NGT, nominal group technique, it's quite applicable in this in the project of this course and in all other engineering projects. Concept generation, problem solving, and decision making. So this is not limited to the concept generation. This could be used in problem solving in your team, for example. If you have a conflict with your friends and there may not be an agreement on a subject, then you can implement nominal group technique together and then resolve that conflict. There are 5 or 6 stages in nominal group technique: reading problem statement, restating the problem, silently generate ideas, collect ideas in a round-robin fashion, summarize and rephrase ideas, and voting. There should be a facilitator in NGT, so some of the team members should be presiding the NGT session. And usually the facilitator read out the problem statement, and then each of the team members restates the problem in his or her own words. So we'd like to make sure that all members understood the problem well. Next, members are given 5 to 10 minutes, 5 to 15 minutes sometimes, to generate ideas silently. Next, each member presents one idea in turn and all ideas written on a board by the facilitator, of course. And then there should be a discussion led by facilitators to rephrase all ideas. Some ideas may be merged, some can be dropped. Finally, the refined ideas. There should be a voting. Each member casts a vote or several, and ideas are prioritized for further discussion. This is quite practical and applicable concept generation method, I suppose, and I recommend you to implement this in your design project. Concept table. In concept table, we simply decompose the problem into sub-problems, or we decompose the system into sub-functions, and we simply look for solutions for these sub-functions. Here, for example, you see you see a personal computing system. This is a rather old example, but this could still be applicable. On the first row here, you can see the functions expected from a personal computing system. And by using the concept generation methods, we can, for example, brainstorming, brainwriting, or group technique, we can create potential solutions for each function here. For example, for user interface, keyboard, touchpad, and writing recognition, video and voice could be the solutions. On the other hand, for power, for example, we may use a battery, AC power, solar power, fuel cell, thermal transfer. So at the end of the brainstorming, the team may have chosen, as for example here, circle it, and heads up display for displaying. And for connectivity and expansion, there are several alternatives here. All are selected. And for power, here you can see these three are selected. And finally, for the size, you can see the tree here. So now we can next create a concept based on these selected solutions. So then for this personal computing system, based on the selections in previous slide, we can imagine a device, wearable, with credit card size components, powered by a combination of solar cells, fuel cells, and thermal heat, having a microphone, camera integrated in the user's clothing, as well as a flexible folded keyboard for typing that's stored in a pocket, and having a display, heads-up display integrated with the user's eyeglasses or baseball hat, for example, having a miniature earpiece microphone used for communication. So it seems to be quite challenging to design such a system, but that is not the subject now we have to consider. Temperature measurement, where we have concept tables. So we are simply trying to evaluate the concepts. There are three sub-functions or systems or modules in a temperature measurement device: thermometer, thermal sensing unit, conversion to voltage, and then display. So there may be three options for thermal sensing. We may use a thermistor, RTD, or thermocouple. For conversion to voltage, we can use an op-amp design or transistor design. And for display, there may be a 7-segment LED So 7-second, that's this, or LCD, just like this, or analog dial indicator, just like this. So we can then construct a tree like this. Our design is right here, and here you can see the sub functions. And for each sub function, we have alternatives, so solutions here. And using these solutions based on a concept to select which solution is most appropriate, we can construct our conceptual solution, conceptual system. Concept evaluation. Now we got a concept and how to evaluate those concepts. This is a decision process, actually, this evaluation. And we have to consider user needs here. This is an input to this decision, engineering considerations. So this is the stage where we have to think about the system, the feasibility of the system, whether that's applicable, that could be implementable or not. So we have to be an engineer now. Okay. Previously, we create ideas, we try to generate different concepts, just forgetting our engineering skills. Generated concepts, so this tree should be somehow used in decision making process, and at the end there should be a ranked concept. So this should not be just a decision that states this concept is selected. Instead, there should be a justification of why that concept is selected. For decision methods, there are three that we are going to discuss here: strength and weakness analysis, analytical hierarchy process, decision matrix, to concept selection. Strength and weakness analysis. For each of the concept, we identify strengths and weaknesses. We assign subjective weights to strengths and weaknesses, just like plus and minus, and then sum them up. So we choose the one having the highest score. That's quite easy, and we have given here an example. Heating a PC card and holding its temperature fixed. There are two solutions here, and strength and weaknesses of each of this is listed in here. We can give minus and pluses here, and then add them up to get the one having the highest score. Analytical hierarchy process, AHP. I will just want to spend more time on that. I find it very interesting and applicable to any decision-making process. In AHP, we have the alternatives right here as usual, and we have some criteria on which the selection will be based on. We simply give weighting rates for each of these criteria, and then we determine ratings for each criteria, for each alternative, and then we multiply this weighting and rating, add them up to get a score at the bottom. So we look into these scores, compare the scores, and then if necessary, we can iterate this. So here is the steps of AHP. We determine the selection criteria, weightings, and then identify and rate the alternatives relative to the criteria, compute scores for the alternatives, and review the decision. So here we are going to apply AHP for car purchasing. Suppose that we would like to purchase a car and we would like to make a decision and apply AHP to make a decision. Here you can see the criteria So in step one, we determine the criteria. The cost will be important, the safety, design styling, and branding recognition. You can increase this, or you can just take 3 or less. So we have to choose the weightings next for each of the criteria. It's relative, of course. We may use pairwise comparison in doing this. For pairwise comparison, we have to compare each criteria to all other criteria with a scale. Here, for example, we choose 1 to 9. So 1, 3, 5, 7, and 9. We can choose 1, 3, 4, or 1, 3, 5, or 1, 2, 3, 4, 5. It doesn't matter, but there should be somehow a pairwise comparison. 1 refers to equal, 3 refers to moderate, 5 refers to strong, 7 very strong, and 9 extreme when we are comparing two criteria. So based on that, for car purchasing problem, we can make such a table. Here we have the criteria, and here as well. So we pairwise compare this purchase cost. So that's going to be a diagonal here, which is unity, because safety is not different or not important than safety. They are the same criteria. If we compare purchase to design, then purchase cost is simply equal importance safety, and moderately more important than design, and then very strongly more important than brand name. So safety is extremely important than brand name, you can see. And the as you can see, once this is 3, then this should be 1/3. So if we simply use the symbols in previous slide, alpha ij is going to 1/alpha ji. And for I equals j, alpha ij is going to be 1. So that is the symbolization that we have used in previous slide. We can then determine the mean, geometric mean. The geometric mean is simply multiplication of those ratings and the nth order squared of nth order root of this will give us the geometric mean. So we add this geometric means up, we got the total geometric mean, and then divide each of this by this total, we get the weighting. So there is a systematic here. It starts with the criteria and how each criteria is important than the others, and then calculating of geometric means and then weighting. So at the end, we got the weights. So here there are 3. It seems that the author of the text prefer to have as SUV, and there are 3 options here: Honda CRV, Hyundai Tucson, and Toyota RAV4. All are 2006 models. Here you can see the cost, and we are gonna show here how to make the decision matrix for cost only. You can apply that to other criteria, of course. These are the costs in USA in 2006. And we can determine the ratings by simply dividing the minimum cost to the cost of each car. And we got the alpha values in here. We can normalize this to the sum. So the alpha coefficients becomes like this. Now we have to apply this for safety, design styling, and brand name. The same procedure. So we'll get alpha values for safety, design style, and brand name in order to proceed to AHP. So here, I simply give the finalized table. As you can see, we have the weights here. We did this. We calculated this. We didn't. We did not calculate this. We are given only um, from the example, and you can see the ratings for the cost we have already calculated in previous slide. These are taken from the example. So we got the score here finally. Okay, it seems that the Toyota RAV4 beats all other options overall, but in some, you can, for example, design styling, Toyota is quite good, while for safety, Honda is better than Toyota. And for brand name, it seems that Hyundai is quite, has a very quite low score compared with Honda and Toyota. So this is how we make a decision. We can refine this decision, of course. We can conclude that scores are quite close. All choices are pretty good. We can say this based on the criteria that we have selected. Toyota RAV4 has the highest score, as we said earlier, and Toyota beats the Hyundai based on design styling and brand name recognition. If cost and safety were given higher weighting, then the Hyundai will beat the Toyota. Concept selection, that's another decision making or concept evaluation method. We, as usual, choose criteria. Usually this criteria is related to the requirements, marketing requirements or engineering requirements, usually marketing requirements. We determine weights for each criteria and then determine the concepts accordingly. We select the baseline concept. So one of the concepts should be baseline concept. And we simply compare all other concepts with the baseline concept. If any concept is better than the baseline, we give +1. If it is equal to baseline concept, give 0. And then if it is worse than the baseline concept, we give -1. So we computed the weighting score for the concepts. We do not include baseline concept, of course. We can retain, update, or drop some concepts and synthesize best elements of others where it's possible. We can update the concept and iterate that until we reach the best concept. So here you can see a concept table. Option here is the baseline. So this is the option 1 baseline, that's the reference, and option 2, 3, 4, and here we have the criteria, we have the weights here, and then we simply compare this one, so this one and this one. If so, the option 2 seems to be better than option 1 in this criteria, so we give +. Option 3 is worse than the option 1 baseline reference, we give -1. So we simply add them up and then we make a decision. We can either combine 2 options, for example, or we can drop 1 and then continue with the options that we have selected. So we can iterate this until we get just one option having the highest score.